Okay, let's go.
Assalamualaikum warahmatullahi wabarakatuh. We are from JCDCS 1432A, and in this video you will able to learn about the application of differentiation, related rates, how it has been used, and the example in the real world. Our group consists of 3 students, which is Muhammad Nur Arif bin Abu Syukur, Fazrul Hakimi bin Fazli Isman, and Muhammad bin Azman. Each of us will explain about the application of differentiation. So, what is related rates? Related rates is a problem involve two or more variables that change at the same time, possibly at different rates. It is a concept in calculus that deals with how the rates of change of related quantities are related to each other. It typically involves situations where the rates of change of two or more variables are connected through some underlying geometric or physical relationship. So now I will explain to you 4 main reasons why we use related rates in real life. First reason is modeling real life situation. Related rates help us understand how different things change over time in real life. For example, if you are filling up a tank with water, related rates can help determine how quickly the water level rise as you keep pouring. It is crucial in various fields such as engineering, where knowing how systems behave over time is essential. So the second point is seeing how changes are connected. These rates show us how changes in one thing can cause changes in another, helping us understand their relationship. Imagine you are inflating a balloon. As the volume of air inside the balloon increases, the balloon's radius also increases. Related rates let us see how thing changes are interconnected and how one affects the other. The third one is predicting future behavior. By knowing how fast one thing is changing, we can predict how other related things will change, which is useful for planning and making decisions. For instance, if you know how fast car is moving, you can estimate how long it will take to reach the certain destination. This kind of prediction is valuable in fields like logistics, transportation, and even space exploration. And the last point is solving geometric problems. We can use related rates to solve problems involving changing shape or size. For example, think about how the surface area of balloon changes as you blow it up. By applying related rates, we can find out how this dimension evolve over time, which is useful in geometry, physics, and everyday problem solving. So now I will give you one example. I will take a melting ice cube as example. When an ice cube melts, it gets smaller as its volume decreases. By using related rates in calculus, we can connect the rate at which the volume of the ice cube is shrinking to the rate at which the length of its side is decreasing. Essentially, if we know how fast the volume is reducing, we can figure out how quickly each side of the cube is getting shorter. These methods help us understand the relationship between the melting process and the changing dimension of the ice cube over the time.
Where x is the object distance from the lens, y is the image distance from the lens, and lastly, 10 is the focal length, which is focus distance from the lens. So basically, we need to find the rate of change for image distance from the lens when the distance is 12 centimeter. We can expect that the rate of change for image distance is negative because. So here is the solution for the question. So first thing first, we have to bring out all the information given, such as the x dt with the value of y and the equation. So the x dt should be positive since the x is increasing. After that, we have to modify the equation given. So the equation will be y in terms of x. So it should be like this: 1 over y equals to 1 over 10 minus 1 over x. And then we will use the butterfly method to make sure that they only have one denominator. So x minus 10 divided by 10x. Since the equation is 1 over y, we just have to twist both denominator and numerator, so the equation will be y in terms of x. So y equals to 10x divided by x minus 10. And then when we want to find dy dt, we will have to use the chain rule method, which is dy dt is equal to dy dx times dx dt. The question already give the value of dx dt, which is 10, and then we just have to find the value of dy dx. So we have to differentiate y in terms of x using the quotient rule method. So dy dx is equals to vu prime minus uv prime divided by v squared. So u should be the numerator and v should be the denominator. So u is equal to 10x, then v is equals to x minus 10. So u prime should be 10 and v prime should be 1. So the dy dx, we just have to substitute all the information we already made. So dy dx is equal to vu prime, which is 10 times x minus 10, minus uv prime. uv prime is 10x times 1. So divide by v square. So x minus 10 square. So we just have to simplify the equation. 10x minus 100 minus 10x divided by x minus 10 square. So 10x will cancel each other. So dy dx is equal to negative 100 over x minus 10 square. So we realize that there is the missing information in dy dx, which is the value of x. So we have to find the value of x first. The question already gives the value of y. So 1 over x plus 1 over 12 equals to 1 over 10. So 1 over x equals to 1 over 12, 1 over 10 minus 1 over 12. And then we just have to use calculator, and then we will get the value of x is 60. So substitute the 60 and in dy dx, negative 100 over 60 minus 10 square, and then we will get the value of dy dx is negative 1 over 25. And then we just have to substitute the value of dy dx and the value of dx dt in this chain rule method. So it will be dy dt equals to negative 1 over 25 times 10, and we will get the value of dy dt is negative 2 over 5, or negative 0.4 centimeter per second.
In conclusion, the application of differentiation helped us a lot in solving the question given. This proves that the application of differentiation is very useful for our life. Not only that, is also used by scientists in conducting an experiment, although it's rarely shown. But in reality, it's a matter which is very important, because if we do not learn about the application of differentiation, we may not be able to achieve the progress that exists now, such as coffee machine that brew and produce coffee according to the set period. Only that conclusion our group made after learning about this topic. I hope you guys enjoyed the video and get something from our group.